Hello, everyone. How are you doing today? Thank you for joining me for this session. My name is Brooke Chen. I'm a Senior Product Manager for AWS Compute Optimizer. I've been with the company for several years. Before this, I worked as a data scientist in the application performance management space and built machine learning models to improve service uptime and availability. I'm excited to be here today to talk about how Compute Optimizer can help you run your applications on AWS efficiently by optimizing your infrastructure setup. In this session, I'll answer 3 questions about Compute Optimizer: what it does, how it works, and why you might want to use it. We'll talk about the concept of right sizing, why it is important, what dimensions you want to consider, also what makes it difficult. I'll explain how Compute Optimizer can make it easy for you through machine learning. We're going to dive into the details of the recommendations offered by Compute Optimizer for EC2 instances, auto-scaling groups, and EBS volumes, and go through a brief demo. By the end of the session, you'll see how you can use recommendations from Compute Optimizer to improve your infrastructure efficiency on AWS and be ready to get started. So what's Compute Optimizer, and what does it do? It's a relatively new service that we launched at reInvent last year. It analyzes the configuration and utilization metrics of your AWS resources. It reports whether you have made the best possible infrastructure choice for your workloads, and generates recommendations to help you reduce costs and enhance performance. All right, but why should you care? And why do you want to learn yet another AWS service? Well, first of all, it's free. Once you opt in, we'll use your default CloudWatch metrics to analyze your usage patterns to find out if you are optimized with respect to your infrastructure setup. Secondly, and more importantly, Compute Optimizer helps you right-size continuously and intelligently through machine learning, so it takes less effort on your part. We automatically monitor and analyze the metrics from your accounts, so you can quickly discover ongoing opportunities to optimize. Our vision is to help you operate your workloads efficiently on AWS. By taking advantage of Compute Optimizer, you can reduce your AWS costs by up to 25%. Okay, and now before we go on, let's take a step back and unpack this answer here. What do I mean by right sizing, and why is it important? Here, we're going to define right sizing as the process of matching the size, the resource types and sizes to your workload requirements. Think of it as grocery shopping. You want to buy just the right amount of food, nothing more and nothing less. Overbuying leads to waste, and underbuying leaves you hungry. Right sizing means provisioning the appropriate amount of resources for your workloads, so you can meet your performance expectations with the lowest possible costs. That sounds great, right? You may say, thanks for the note, and we'll take care of it. Why do we need your help? Well, as it turns out, right sizing is not easy, and it's especially challenging when you have a large infrastructure footprint. As to why it's not easy, I'll give you 2 reasons. Reason number 1, there are too many options. To satisfy customers' unique business requirements, AWS offers a wide selection of compute options. For example, we offer more than 350 types of EC2 instances for virtually every workload you can imagine. Not only do you need to figure out the type of instance you want, you also need to pick a size. Should you size up to be safe or start small? As we continue to come up with more compute options to provide you with greater customizability, the choice only gets more difficult. Let me walk you through how you pick an EC2 instance. First things first, You want to look at the defining characteristics of your workloads through metrics such as CPU, memory, network usage, I/O, and throughput of your attached EBS volumes. You need to collect these metrics and look at things like the average and peak usage. And you need to project how these usage levels will translate to another instance that you're considering. And to do that, you will need to know the exact specs of hundreds of instances that we offer and experiment with a long list of possible configurations. It's a tremendous amount of time to do this for even a single instance, let alone for a production fleet with hundreds of instances. So what's the number 2 reason besides choice overload? Well, it's just the simple fact that things change. You may have made the right choice when you first launch your applications, but new opportunities to optimize can emerge as your workloads grow and evolve. Ideally, you should reevaluate your infrastructure choice every time there's a change in your application environment. For example, when you re-architect your services or when you launch new features. Right-sizing requires ongoing efforts. Think of it as flossing your teeth. It doesn't really work if you only do it once a year. If you have a large fleet that consists of hundreds of even thousands of instances, you are practically a giant armadillo. And fun fact, they can have as many as 100 teeth. Now, imagine flossing 100 teeth every single day. To continuously right-size a large infrastructure is just like that. It's often an operational nightmare. Of course, some customers choose to pay for third-party softwares or build in-house optimization teams. But these are expensive. Just imagine hiring somebody to come over to your house and floss your teeth for you. Many customers end up leaving their resources incorrectly sized, either because they are paralyzed by the effort required for the analysis or made the wrong choice to begin with, or because they fail to re-engage and reevaluate when their application environment change. As a result, they overpay for their infrastructure or run into performance issues caused by suboptimal setup. So here's why you want to use Compute Optimizer, because it helps you solve both problems. It helps you make the right choice by feeding your default CloudWatch metrics through machine learning models, predicts how your workloads will perform across different hardware configurations, and identifies the most suitable alternatives if your current choice can be improved. It helps you continuously right-size by monitoring your usage and providing you with ongoing advice to help you discover new opportunities to save. Instead of spending 2 hours in the bathroom to floss all your 100 teeth, you can just log into Compute Optimizer console and review your optimization status. Not only does Compute Optimizer monitor, aggregate, and analyze your AWS usage on your behalf, it also provides visualization of historical and projected future usage. We do this to make our recommendations more understandable and intuitive, and by helping you estimate how usage level will change with each recommendation, we want to make it easy for you to decide what option gives you the best price-performance trade-off. If you had tried Compute Optimizer before, you may notice that there are now 4 additional metrics for EC2 instances. We just added instance-level EBS throughput and IOPS consumption to help you avoid mismatch between your volume and instance choices that could be affecting your EBS performance. In addition to leveraging these insights for cost optimization, you can also use them to troubleshoot performance issues, such as when you're not experiencing the IOPS or throughput that you expect in your configuration, and ensure that your EC2 instance bandwidth is not the limiting factor. Now, let's take a look at an example recommendation for an EC2 instance. We have an N5 2x large machine that's running a workload with strong daily pattern. The CPU usage shoots up to 40% during the day and drops down to 10% every night. We've got pretty stable memory usage and extremely low network and EBS IOPS. So Compute Optimizer will gather all these usage metrics over the last 14 days and process them together with instance metadata to help you identify better and less wasteful alternatives that can support the same level of performance. Here, we'll provide you with 3 options with varying amount of savings and performance risks. Both options 1 and 2 are considered low risk because you can still have a lot of CPU headroom. But if you adopt either of these suggestions, you only need to pay half of the price you're paying now. The third option, an R5 large, gives you even greater savings, but it comes with a smaller buffer for your CPU usage, and therefore will mark it as a higher risk option. Since our launch at reInvent 2019, customers have been telling us that they want us to help them optimize their EBS volumes together with their EC2 instances. We're excited to announce that we're now providing recommendations for EBS volumes. You can get Compute Optimizer recommendations for general purpose SSD volumes, including GP2 and GP3, provisioned IOPS SSD volumes, including IO1 and IO2. We monitor things like the I/O profile and configuration of your instances and volumes, and validate whether your current choice is able to handle the expected EBS performance. We might find your volume setting to be either optimized or not optimized, and we'll consider it optimized if we think the volume is appropriately provisioned to run your workload. If we decide that your choices is not optimized, we'll help you identify the optimal provisioned IOPS settings and sizes for your EBS volumes based on your performance needs. Again, you don't have to do anything if you already enabled the Compute Optimizer, because all the metrics we analyze are published by AWS for all EBS volumes by default. Specifically, we will support provisioned IOPS and throughput recommendations for GP3 volume, provisioned IOPS recommendations for IO1 and IO2 volumes. We'll also help you identify under-provisioned GP2 volumes that can benefit from higher performance settings. With these recommendations, you can easily save costs and increase the performance of your EBS workloads. And just like before, you can have them for free. Now, let's take a look at an example EBS volume recommendation. Here you have an IO1 volume. It's sized to be a little over 4,000 gigabytes with 20,000 IOPS. Over the last 14 days, your EBS usage is pretty consistent. The average IOPS is around 2,700, but occasionally goes up to 5,000. Your current EBS volumes provide you with more than 400% of performance headroom, and therefore we're recommending you to reduce your IOPS settings to be more economical. Here, we offer 3 options, and they come with varying amount of performance risk and saving potentials. Again, performance risk is related to the amount of headroom that the recommendation offers. Options with bigger headrooms are lower risk, but also come with slightly smaller saving potentials. Now, let's jump into a demo. I'll give you a more detailed walkthrough, and you can see how the service works in real time.
I'm using an account that has not enabled the Compute Optimizer before. Let's go ahead and enable it together for the first time. You can find Compute Optimizer by typing into the search box or in the drop-down menu under Management and Governance. Now let's get into the console. Here you are seeing a product overview, which we covered earlier in the session. So I'm just going to go straight to get started. Here we're in the opt-in page. It's basically saying that you are allowing Compute Optimizer to pull usage data from CloudWatch to generate recommendations, which will refresh daily. You can see there are 2 opt-in options. If my account is the management account of an AWS organization, then I can enable all the accounts in my organization all from here. Or I can just enable the service for this individual account, and that's what I'm gonna do. This page should be pretty straightforward, but there are two things I would like to call out. One, in order for Compute Optimizer to factor in my memory usage in its recommendations, I need to enable the CloudWatch agent on my instances to publish memory metrics, because memory usage isn't monitored by default. I won't have time to show you the detailed steps in today's demo, but we do encourage you to install the agent, which will publish memory data to CloudWatch and further improve the recommendations. 2. There's a note here about service linked role. This is just a reminder that Compute Optimizer will use the service linked role to collect and analyze CloudWatch metrics on your behalf. If you encountered any issues during the opt-in process, you probably want to look at your IAM permission setup and policies. For this to work seamlessly, you may need to reconfigure permissions so that whatever IAM entity you're using can create a service linked role for Compute Optimizer. Okay, let's go ahead and opt in here. And this is it. Over the next 12 hours, Compute Optimizer will start analyzing the EC2 instances, auto-scaling groups, and EBS volumes in my account. It will tell me if my current choices are optimized and make recommendations based on its findings. And just a quick note here, our recommendations are only available for those resources that have been running for at least 30 consecutive hours. For now, there's nothing to see here because I just turned it on, and it takes up to 12 hours to conduct an initial analysis of your account. Let's go over to another account that has had a Compute Optimizer running for a while, so we can see some recommendations. Okay, now I'm logged in with a different AWS account. This one has had a Compute Optimizer enabled for a long time, so we have a lot of recommendations to dig into here. This is the Compute Optimizer dashboard, and it summarizes how we're doing with respect to right sizing. I want to direct your attention to two things. First, look at the upper right corner and see where it says global. Compute Optimizer offers you a global view of your resources. Our recommendations are available in 16 regions. By default, I'm only looking at resources in US East 1. If I want to look at everything across all regions under this account, I will just remove the filter. Let's give it a minute and wait for it to grab the data. So now we've got a truly global view by removing the region filter. I can also select multiple regions. For example, let me add Oregon to my list of filters. As you can see, I've got 2 more over-provisioned EC2 instances and 2 more optimized EBS volumes added to my dashboard by including Oregon. For now, let's remove it and focus on US East 1. Second, still in the upper right corner, you can see a filter for account IDs. Because we are integrated with the AWS organizations and I'm using the management account, I can see other accounts in my organization in this drop-down list. You can easily jump to Compute Optimizer dashboard of another account in your organization and see their optimization status. Okay, let's refocus on the main dashboard and take a look at what we have under EC2 instances. It's telling me that I'm 70.6% over-provisioned. So that's not very good, because it means I'm overspending. As you improve your resource efficiency by implementing our recommendations, you should see that the optimized portion, that's the section in green, expands over time. We have 3 instances that are optimized, which means our instance choice is appropriate for our workloads. On the left, we have 2 instances that are under-provisioned. This is because there are some kind of resource constraints and we can benefit from sizing up. On the right, we can see that we have 1 auto-scaling group that is not optimized. We'll take a look at what we can do in a second. The good news is that we do have the majority of our EBS volumes is optimized. If you ever have questions about what we mean by optimized, under-provisioned, over-provisioned, or not optimized, you can click on this little info button here and you'll pull up a help panel on the right. It will tell you what the findings mean and how you should interpret them. Okay, now let's go and see some recommendations. Let's start with EC2 instances. To view recommendations for all my EC2 instances, I just need to click here, and it takes me to a list view. Here you can view the details such as findings corresponding to each instance, the current and recommended instance types, the estimated price differences by the hour, and number of attached EBS volumes. You can modify this table here by clicking on the gear icon in the top right corner. Here, we can enable additional columns to change the estimated price difference to reflect RI prices or exclude instances that belong to an auto-scaling group. There are quite a few things we can do here. We could add a price difference in percentage or get an estimated monthly savings instead of hourly. Let me turn a few of these options on and see what we have. So now I have both the absolute and relative price differences compared to what I'm currently paying. I find the relative percentage and monthly savings columns really helpful because I'm too lazy to do the math in my head. You can include additional information in the summary table, like on-demand versus savings plan hours. Now, let's take a look at an over-provisioned instance. When I click on the instance, it will lead me to the detail page where I can get more information beyond the findings and price information here. We have three options. The graphs are showing that the network and EBS usage is somewhat spiky, but the CPU utilization is pretty flat at just under 30%. The model is saying that we want to consider using an R5X large or a T3 2X large instead of an N5 2X large that we currently have. We can look at the price difference across each of these and gauge how much money we can save. Given that we have quite a bit of network usage and a relatively small CPU footprint, the R5X large gives you more savings with roughly the same level of performance risk as sticking with my N5 2X large. We can see the usage history from this panel of graphs in the bottom of the page. You can change the statistics from average to maximum, and change up the time range to cover the last day, the last 3 days, the last week, all the way up to the last 2 weeks in order to see different granularity of the data. Now, on the top left corner under the instance ID, you can see there's another tab with information about the attached EBS volumes for this instance. Let's click into that. Here we see just one GP2 volume attached to this instance, and it's optimized. Let's click into the finding and see what we have. The layout of the EBS recommendations is similar to the one for EC2. We have the list of options up top and some metric graphs at the bottom. Here we have volume read and write throughput, which measures operations per second, read and write bandwidth, which represents the amount of data transferred per second, and IOPS burst balance for GP2 volumes. So here it's saying that there's nothing problematic about how my GP2 volume is set up here. But it should be pretty obvious that I can get better performance with lower cost by switching to the new GP3 volume. Therefore, even though the finding is optimized, we may still want to change the volume type based on the recommendation. Now let's take a look at an example EBS volume that's not optimized. Here we have an IO1 volume. We're indexed really high on write throughput and bandwidth, so Compute Optimizer is recommending us to update the IOPS setting to achieve better performance. Option 3 is a recommendation to move to IO2 with the same IOPS setting as option 2. Although there is no difference in price, you get greater durability and 10 times higher IOPS to storage ratio for your money. Finally, let's see what recommendations Compute Optimizer has for auto-scaling groups. We have just one here, and it's not optimized. Let's take a look. This auto-scaling group is using 4 C5X large instances. You can see that we have extremely low CPU usage, and is recommending us to size down. And consider changing our C5X large instances to T3 large, N5 large, or R5 large. Let's turn on the savings in percentage column here. Now we can see that if we go with the first option and move to T3 large, it will slash our bill by more than half. The other two options will give us substantial savings as well, but T3 large is the clear winner here. Alright, that wraps it up for the demo. Let's go back to the session.
So hopefully that was helpful. In addition to the console experience that you just saw, we also provide a set of APIs that allows you to view the recommendations across multiple regions and multiple accounts. You can also export your recommendations to record them over time and share the data with your teams. You can see Compute Optimizer recommendations in multiple places across AWS. You can access our recommendations in Amazon EC2 Console, AWS Cost Explorer, and AWS Systems Manager. So that's everything I want to cover today. To recap, we went over 3 things. We talked about the importance of right sizing, what makes it difficult, and how Compute Optimizer helps you simplify the process. We reviewed the kind of recommendations that are available in Compute Optimizer, and walk through how you can use these recommendations to optimize your EC2 instances, auto-scaling groups, and EBS volumes. Thank you again for tuning in, and don't forget to leave your feedback at the end of the session.